Hello everyone and welcome to today's video. This lesson we're gonna dive into the echelon form and the reduced echelon form. So in order for us to get the echelon form, we have to satisfy three conditions. Let's start with the first one. The first one says all non-zero rows are above any rows of all zeros. What it basically means is, let's just take a look at this matrix. By looking at this matrix, we see that a row that has only zero numbers is the third row, right? So if you have a row that's only zero, it should be at the bottom, right? And for instance, if we take a look at this matrix, we can see that the row with only zero numbers is in the middle, which violates the rule. So this would not be an echelon form. Now let's take a look at the second rule, which is each leading entry, or we call it pivot, of a row is to the right of the pivot in the row above it. Let's talk about what a pivot is. A pivot is the first non-zero number of a row, right? In this case, like when we take a look at this matrix, a pivot would be 1. In this case, it would be in row 2, it would be 2, right? We can also do something like this, right? In this case, the pivot would be in row 2, the pivot would be 1 over here. So to satisfy the echelon form, the pivot has to be to the right of the row above. So let's take a look at this matrix. So as we can see, each leading number of the next row is to the right of the row above, right? So row 1 has leading number in the first column, row 2 has its leading number in the second column, and the row 3 has its leading number in the third column. And just to make a counter example, let's take a look at this matrix. So in this example, the row 2 satisfy the condition, right? But the row 3 doesn't, because it's not to the right of the row above. So this would be a no, and this would be a yes. And the third condition is all entries below each pivot should be 0. This should be very self-explanatory. So basically, it should look something like this. The pivot number in the first row, it only has zeros below, and when we look at the pivot number at the second row, it also has zeros below. And let's just look at a counterexample when this would not be true. For instance, if we have something like this, right? So the pivot number doesn't have only 0 numbers below, right? In this case, it has 1. And sometimes we might have more than 3 rows, and it can look like this. So we might have a case like this when everything up to the row 2 satisfy the condition, but when it comes to the row 3, the row 3 has a non-zero number underneath, which violates the condition. Now let's talk about the reduced echelon form. Just gonna quickly erase everything. To get the matrix into the reduced echelon form is very easy. We need to satisfy three conditions. The first condition is it already should be in the regular echelon form, right? The second condition would be that each pivot number equals 1. And the third condition is that each pivot is the only non-zero entry in its column. Let's take a look at this matrix. This matrix is in the reduced echelon form. It satisfies all of the conditions from the regular echelon form. All of the pivot numbers are 1. Each of the columns has only one non-zero number, right? There are zeros underneath. Then for the column 2, for the pivot in the column 2, there is 0 above and underneath. And for the pivot number in column, and for the pivot number in the row 3, we have only zeros above. Once you get the regular echelon form, it's very easy to turn it into the reduced echelon form. I also wanted to talk about the rule number 2, pivot equals 1. Sometimes some textbooks require this rule for the regular echelon form. It depends on the textbook, it depends on professor. I would just suggest listen to what your professor says and what he requires because your grade depends on it. But also, as a rule of thumb, just get that pivot number equals to 1 all the time. It makes your work easier. It's going to take maybe 5-10 more seconds to do that, but get that one all the time. It doesn't matter if it's a reduced echelon form or a regular echelon form. Get the pivot number equal to 1 all the time. And that's it for this lesson. Thank you guys for watching. And in the next lesson, we're gonna get to the Gaussian elimination. We're finally gonna learn how to solve the matrix and get the results. Awesome. Thank you so much, guys, for watching, and I'll see you in the next lesson.